Okay, now I'm going to give some hints on AP question 80. That's due Tuesday for the in-person people and Wednesday at the earliest for people online. There's always going to be a delay because of technology. Okay. So I don't expect that you're like Einstein level geniuses and you're just writing everything down, instantly memorizing because physics is so fascinating. Okay, so I would really write down the formula that they're giving you. Velocity as a function of time equals a, and I am sad that we can't just sit in our groups and talk to each other because that helps so much in physics. Okay, and then I would write down the given information. If you are super on the ball, you can pat yourself on the back. You might just write these plugged in. Especially, you might be tempted to write A equals V0, or V0 is 2 meters per second, and just throw it in the equation because that's right. But then what's B? Okay, B, there's a 1 over time. It's this weird coefficient. So that's also fine. If that confused you, then I would do what I'm doing. I'm always confused. Maybe that's how I'm good at physics. We just fight through confusion. Okay, and then we want, so time is limited, inclusive, 1.0 seconds to 8.0 seconds. There's our time set. Determine the acceleration and position at t equals 2 and t equals 5. And at 1 second, x equals 0. So that's really important. x1 equals 0. So not x0 equals 0, but at the start of this interval, 1 to 8, x equals 0. Okay? All right. So really they have two questions. At t equals 2, they want the acceleration and position. And then at t equals 5, they want the same things, right? Does it say 4? I don't read 4. Uh-oh. Pretty sure it's 2 seconds and 5 seconds. Good. No, it's good for checking me. Boy, I noticed that over the summer. The details escape me more now than they used to. I think it has something to do with stress, and I'm not actually that old. Okay. Well, with our new powers of calculus, acceleration is really easy. So, in fact, let's see here. Let's call this. Oh, well, we can just write acceleration at any time. I would write down dv dt to track what I'm doing, and then see what I do. Well, the constant 2 meters per second, that just goes away. Okay, and then I'm going to divide by the new exponent, which would be negative 2. So I ended up with b over negative 2 t to the negative 2 power. Nope, that's wrong. I did derivative. So I do decrease it by 1, I divide it by t, but it's the old exponent. The negative 1 comes out first. I just wrote it down and I still mix it up. It's natural. It's okay. Okay. Oh, so then if I had a nice chart, I could say, okay. Oh, let's get both my formulas out there. And that's where I need extra. So I actually want to check and see exactly what it says on your equation sheet. And I've been trying to keep one handy. And And then I just pile everything on top of it, as if it doesn't matter. Come on, AP equation sheet. I don't spy it. Oh, there's one. I think I can. Yep. Fantastic. Okay. So write down what you did. I'm going to do the antiderivative with respect to time. So I'm adding 1 to the time. I'm probably writing too big now. So there we go. I have an a, and it's just divided by 1 times t to the first power. Okay, the new exponent, not the old one. Okay. I have a b, and then I have to do the integral of t to the minus 1. So you might think that one was 0 with respect to t, because right, if I add 1 and my new component is 0. Oh my word. Did they just... Oh. I know what they did. They sure did. Okay. I wish I had... Okay. We'll demonstrate for you, even if I have to erase it to fit on this sheet. What they have... Oh, there we go. They have two things on the equation sheet. They say d dx, which is just a different variable from t. I'll just copy theirs instead of... Or would you rather that I translate? We're working all in t's, that's better. Okay. They have d dx acts on or multiplies ln. I always want to write an h instead of an l and an n. ln of ax, at, it would be if I translate it. And a is a constant, equals just 1 over t. Well, t to the negative first is 1 over t. And they also have antiderivative integral sign, dt, there it is on top, divided by t plus a equals natural log times the absolute value of t plus a. They have x's, of course, on the real sheet. Interesting. Well, we just have the b multiplied out front. Okay, we don't have anything in there multiplied with t. So actually neither of these really matter. Why do you suppose, if it's got a multiplier, kind of like my b, I can just ignore it? At least for the derivative. I'm going to erase. Isn't ln of a times t equal to ln a plus ln t? If I have two things multiplied inside a logarithm, can't I take separate logs and add them? Pretty sure that's how log works. Well, if you take a derivative, you're allowed to do that. Derivative is just a multiplication operator that acts on things. So if I split them apart, the derivative of a constant, natural log of this number a, is always 0. Constant numbers don't change. So I really just need my t if it's multiplied. Now that can get a little tricky. This b over negative 1 is a constant out front, so it doesn't disappear. But it's just like any other number. It's like my capital A from the examples. Okay, can I erase this here in black just to get some more room? It's on your equation sheet. So just mark that it's relevant. Okay. So we have b, and it should be negative b now, because divide by negative 1. And then to go from t to the minus 1 to there, I just need natural log of t. Absolute value of t, please. There's no such thing as a natural log of a negative number. But we're constrained, so maybe we don't really need that, because we're constrained from positive 1 to positive 8 anyway. And then there might also be a constant. Okay. If x at 1, and here's why they gave 1, okay, when time is 1, x is 0, okay, so I have whatever this, the a is 2, so I have 2t minus b is 0.25, that's 1/4. So let's do natural log of t over 4. But when t is 1, what's natural log of t? 0, isn't it? Yeah. Some people are waking up. Okay. And then, so plus c. So this is 0 when t equals 1. Whoops, not equals, plus. So I have 2 minus 0 plus a constant. So the constant must also equal negative 2 in order for x1 equals 0 to be 0. So now I actually have equations. There's x of t, fully fleshed out. Okay, and there's a of t. Whoops. Since this is so easy, let's put minus 1 over 4 for our acceleration, 0.25. Okay, well, then at t equals 2 and t equals 5, you just plug in those t's to that equation for acceleration, and this one for position. Whoops, I really wanted red. I mean, oh well. Christmas colors. Wanted it to match. Okay. Any questions? That's one of the later problems, so that's fine if you're not that far today. Let's use my hints. I'll stop recording.